And here we go. We got our third type of solving a system of linear equations. We looked at graphing, we've looked at substitution, and now we're going to look at elimination. So when we use elimination, we are going to be adding or subtracting equivalent forms of an equation in order to eliminate one of the variables. So we'll add or subtract equivalent forms to eliminate. So what we're looking for here is we're trying to get the coefficients, the number in front of the variable, to be the same for either the x or the y variable. It doesn't matter which one. And to be honest with you, the sign doesn't matter very much either. But as long as the actual number is good, then we can add or subtract the equations together, and that will turn the x or the y variable to 0, which will eliminate it. So let's see how we do this. Example number 1. Solve the following system of linear equations. 2x plus y equals 9, 3x minus y equals 16. Well, look at your x's. You've got a coefficient of 2 and a 3. Well, they're not the same. But look at your y's here. The coefficient is 1 and 1. This is plus 1, this is minus 1. That's okay. But the actual number here would be 1 and 1. So because my y's are y and negative y, I need to add or subtract these together in order to eliminate it. Well, how do I get to 0? Positive 1 and minus 1, I'm going to add these together. So if my signs are different, I'm going to add. Signs are different. If I look at this and the signs are the same, I wouldn't be adding, I'd be subtracting. But these are definitely different signs, positive 1 and negative 1. So I'm going to add these two equations together. So I'm going to add. What's 2x and 3x? Well, that's 5x. Positive 1 and minus 1 is 0. It disappears, so I don't have to write anything down there. And it equals to 9 plus 16, which is 25. Now I'm just simply going to solve for my x. Right now it's being multiplied by 5, so I'm going to divide by 5. And the x value is equal to 5. So right there I've solved for my x. I now need to figure out what my y is going to be. So I can choose either equation, it doesn't really matter. I'll choose the first one, and I would get 2x plus y equals 9. I'm going to change all my x's to 5. So this is multiplication, so it's 2 times 5 plus y equals 9. I know 2 times 5 is 10, so that's 10 plus y equals 9. And now I got to get the y by itself, so I'm going to say this is positive 10. I'm going to subtract 10. 9 minus 10 is negative 1. So y is negative 1. So my x value that satisfies both equations is 5. So y is negative 1. So the point I just made is 5, negative 1. And of course, like everything in this unit, I can pull off a quick check. Let's do that to make sure that I have the correct answer. I go to the original equation, change my x's to 5 and my y's to negative 1. 2 times 5 plus negative 1 should equal 9. So this is 10 minus 1. 10 minus 1 is 9. Bring it down. Yes, I got a good check for the first equation. And of course, we got to make sure this is the exact combination, so we got to use both equations. 3 times 5 minus negative 1 is going to be 16. Well, 3 times 5 is 15. Subtracting -1 is the same as adding, so it's +1. 15 and 1 is 16. So yeah, we seem to have a good equation, good solution here. It's really important that you bring the addition or subtraction sign and then put the value of y in brackets. You can see here that if I didn't put the negative sign here, I might have mistaken that for addition or subtraction, sorry. So negative and a negative, add 16. Okay, so that was a fairly straightforward one because my y's were already having the same coefficient. But what happens when they're not the same coefficient? Solve the following system. 4x minus 3y equals 25, and negative 3x plus 8y equals 10. So I got some options here. Neither the x's or the y's are the same, so I can make the x's are the same or make the y's the same. It really doesn't matter to get the same answer in the end, but I think the numbers that are smaller, having smaller coefficients, so in this case it's the x's, it's a little easier to work with. So this first equation, I'm going to times it by, well, what's a lowest common multiple between 4 and 3? Answer here is 12, so I'm going to try to make it into 12. So I'm going to take the first equation and times it by the coefficient of the second. In this case it's 3. I'm going to take the second equation and times it by the coefficient of the first equation, which is 4. So this will be 4x minus 3y equals 25. This will be negative 3x plus 8y equals 10. So now I simply got to distribute the 3 to each part of my equation. That will be 12x. 4 times negative 3 is negative 9y equals 25 times 3 is 75. And do the same thing with the second equation. So multiply it by 4. 4 times negative 3 is negative 12x. 4 times 8 is positive 32y equals 4 times 10 is 40. So now you ask yourself, am I going to add these equations together to eliminate the x's, or am I going to subtract them? Well, my signs are different, so I'm going to add. Put a big plus sign here. So 12 plus negative 12 is 0. It disappears. Negative 9 plus 32 is 23y. And 75 plus 40 is 115. Now I'm going to solve for my y, divide each side by 23. And my y is going to equal 115 by 23 is 5. So there I go, I've just found the y for my solution. Now I got to find the x. I'm going to go into one of the original equations. And again, it doesn't matter which one. I like the first one. So 4x minus 3, I'm going to change my y into 5, equals 25. So I got 4x, negative 3 times 5 is negative 15, equals 25. I'm going to add 15 to both sides to get rid of it. 4x equals 25 and 15 is 40. And finally divide by 4, and my x is 10. So there is the x solution to my equation. So the point that I just made that satisfies both is 10 and 5. And again, let's do a quick check to make sure that I am actually right. Start with the first equation, changing the x's to 10 and the y's to 5s. 4 times 10 minus 3 times 5 should be 25. 4 times 10 is 40, minus 15. 40 minus 15 is 25. And yep, that's a good check. And then we'll go with the second one. Negative 3 times 10 plus 8 times 5 should be 10. Negative 3 times 10 is negative 30. 8 times 5 is positive 40. Negative 30 plus 40 is 10. And yep, that's what I got. So I do a check. Seems to work. So my answer was 10 and 5. Okay, so now what happens in our very tough equations where I've got fractional coefficients? Well, in fractional coefficients, again, we've got to get the LCM, lowest common multiple, of all denominators. So let's do the first one here. 3/4 x minus y equals 2. Well, there's only one denominator, so the LCM is 4. So I'm going to times everything by 4. So 4 times 3/4 x minus 4 times y equals 4 times 2. So the 4's eliminate, give me 3x minus 4y equals 8. Okay, let's take a look at my second equation, the LCM of denominators. Denominator of 8, denominator of 4, LCM is 8. So I'm going to times everything by 8. So 8 times 1/8 x minus 8 times 1/4 y equals 8 times 2. So 8's will eliminate, give me x. Negative 8 times 1 is negative 8. Divided by 4 is negative 2y equals 16. Okay, so I've got my fractional coefficients taken care of. I now have to see, does anything line up here? So I've got 3x and 1x. Well, that's not the same. I've got negative 4y, negative 2y. Well, that's not the same. So I'm going to have to change some of this. Well, I think it's pretty easy to get my x's the same, because this is 1x. I know I want it to be 3x, so I'm going to times everything by 3. So times 3. So I've got 3 times x gives me 3x. Negative 2 times 3 is negative 6y. And 16 times 3 is 48. So here are my two equations. 3x minus 4y equals 8. 3x minus 6y equals 48. Now I have to eliminate the x's. So I ask myself, do I add or do I subtract? Well, the signs here are the same, so I'm going to subtract. In my previous examples, the signs were opposite, so I had to add. Here they're the same, so I'm going to subtract these guys. 3x minus 3x is nothing. It disappears. That's what I want. Negative 4 subtract negative 6. Remember, subtracting a negative turns into addition. So I really say to myself, negative 4 plus 6, which is 2. So I get 2y. Then I've got 8 minus 48 gives me negative 40. So I have to isolate my y. I'm going to divide each side by 2. And my y is going to be minus 20. So I've just calculated the y value that works for both equations. Now let's do the x. Again, I can choose either of my formulas. If I look at my original formulas, I think this one's a little bit easier to work with because I have less fractions. So I'm going to use that one. So I've got 3/4 x minus y equals 2. I'm going to change the y's to negative 20. But watch here, I still have that negative sign. So I get 3/4 x minus negative 20 equals 2. I'm going to put the negative to the negative 20. So that's 3/4 x plus 20 equals 2. Bring the 20 to the other side, so it's going to be subtracted. 2 minus 20. So 3/4 x equals negative 18. Now I got a fraction here. So there's a couple ways I can deal with this. The first thing I'm going to do is I'm going to get rid of the division by 4. So I'm going to times everything by 4. Times 4 and times 4. That 4 and that 4 cancel. 3x equals negative 18 times 4 is negative 72. Divide by 3. Divide by 3. And my x equals negative 72 divided by 3 is negative 24. And I found my x version of it. Now this step here, technically I could have multiplied this by the reciprocal, which would have been 4/3. Would have got me the same answer a little quicker. But I did the same thing, right? Multiplied by 4, divide by 3 is the same as the reciprocal 4/3. So now I can do a check. Go to green and see a check. I'm going to go back to my original equations, changing my x's to negative 24 and my y's to negative 20. So I have 3/4 times negative 24. Subtract negative 20, and this should equal 2. 3/4, 3 times negative 24 divided by 4 is negative 18. Plus 20. Negative 18 plus 20 is 2. And yep, got a good check here. Now let's go to our second equation. 1/8 times negative 24 minus 1/4 times negative 20. This should equal positive 2. 1 times negative 24 divided by 8 is negative 3. Negative 1 times negative 20 is positive 20. Divided by 4 is plus 5. Negative 3 plus 5 is 2. 2 is 2. I get a good check here. So I've got the correct answer. Looks good. And finally, let's go to our last example. We know our last examples for this unit have been us creating the equations. So the sum. Well, there's a keyword for us. What's the sum mean? Well, sum means addition. The sum of two numbers is 90. The larger number is 14 more. Well, what's 14 more mean? More is another way we say plus. then 3 times the smaller number times its multiplication. So again, we have to realize that we're going to let the first number, we're going to call that, well, we can call it X, we can call it Y, well, let's call it A for today. And the second number, well, let's call that one B. No problem. So our first sentence gives us our first equation, the sum of two numbers. Adding two numbers is 90. So first number plus my second number equals 90. The word is usually indicates the equal sign. So the sum of two numbers on one side of the equal sign, 90s on the other. The larger number, okay, the larger number was A, is, well, is equals 14 more. So 14 plus 3 times the smaller number, which is B. Times, let me indicate just by having the two numbers beside each other. So A plus B equals 90. Sum of two numbers is 90. The large A equals 14 plus 3B. The larger number is 14 more than 3 times the smaller. Okay, so the first thing I see here is that my A's and B's are on different sides. I really don't like that too much. So let's bring all my variables to the other side. So A and B equals 90. Oh, that's good. A plus B equals 90. Here is the A. So the A is already on the left, so I'm okay with that. I want my B, so this was positive 3B. We'll flip the sign, minus 3B equals 14. So now I've got A's and B's on the same side. Which one do I want to eliminate, the A's or the B's? Well, the A's have the same coefficient of 1, so let's do that. If I eliminate my A's, do I have to add them or do I have to subtract them? Well, I have to do the subtraction because they're the same sign. So I will subtract these guys. A minus A disappears, so I don't have to even write it down. Positive B minus negative 3B, two negatives, that's addition, so that's 4B, equals 90 minus 14, well, that's 76. So now I divide by 4, and I'll get my B answer. 76 divided by 4, well, that's 19. So I know my B, which is the second number, is going to be 19. Well, what's that first one? So again, I go back to either one of my original equations. I think this equation is a little bit easier to work with. So A plus B equals 90. Change my B to 19. A plus 19 is 90. Isolate the A and subtract 19. So 90 minus 19. My A, or the first number, is 71. So I've got my first number at 71, my second number at 19. So let's do a quick check to make sure these are the correct answers. Go to the green pen, and the first equation is A plus B is 90. My A is going to be 71. My B is 19. 71 and 19 is 90. So yep, looks like I got a good check. And now we'll go to the second equation. A equals 14 plus 3B. This check's a little more difficult because my A's and B's are on the different sides. But let's work it out. My A is 71 equals 14 plus 3 times B, and my B is 19. 14 plus 3 times 19 is 57. 14 and 57, well, that's 71. 71, check. So it looks like I got a good solution. So our third way to find the solution is through elimination. Let's do some textbook work. 437, 1 from the A, 6 from the B, 1 from the C.